Good evening there, Earth Science students. This is Mr. Rankin here, and I'm trying to teach you the two methods of weathering. Alright, last year we dedicated two class lessons, one for chemical, one for physical, so I'm trying to combine them here into one lesson. Alright, so teaching point for today to analyze the physical and chemical breakdown of rocks. Do now. During the course of this video, please open up your notebook and write the following. 1. Teaching point and table of contents. 2. Teaching point for your notes. And 3. The notes that are in yellow font. The vocab terms for this unit will be provided by me, and they must be entered in the glossary. Alright, let's begin. So we have physical or mechanical weathering. This is the process by which rock is broken down through physical means, which changes mainly to its shape. So the regions can interchange this word, mechanical and physical, and they both mean the same thing. Our first type of physical weathering is ice wedging. The definition: when liquid water found in fractured rock expands and wedges it open, aka also known as frost wedging and freezing and thawing. This is occurring now currently in the wintertime when we have melted water melted ice water from previous snowstorms or even rain. And once the sun goes down, the temperatures become cooler, below freezing, and that water will freeze. And you have the constant cycle. Sun comes out, it thaws out. Sun goes down, it freezes. It goes back and forth, and eventually you can make these potholes that occur in the ground. On major thoroughfares like expressways and highways and byways and streets and avenues and lanes. Alright, the second thing is abrasion. The collision of rocks with other rocks, which can occur as rocks tumble along river bottoms or during windstorms in deserts. Great example, we have in the desert, we have wind. If wind takes sand in one general direction, it can begin to weather down a bigger rock. Could be like a cobble or boulder. This could also happen in running water. So rivers, streams, creeks, or brooks, and whatever is happening down here, these are all bigger sediments that roll and bounce, and when they do that, it can abrade and make the particles more rounded. Going back to the desert, sand, if you go back to page 16 of your reference table, we know that sand is made up of quartz, and quartz has a hardness of 7, which makes it abrasive. And we can use sand with sandpaper, to sand down objects like pieces of wood. Instead of having it splintered, we can smooth it out. Great example of that is a thing called sandblasting. So here's a machine that's shooting out sand at very high speeds, and it's actually cleaning off these pipes that were really corroded, with a lot of rust. So as you can see, it's cleaning up really nice. And companies, if there's a lot of graffiti on walls, you can actually use sandblasting to take off that graffiti. Alright, pause this. Get back to the lesson. Alright, next one is organic activity. This is pretty funny. Most students like this picture on the right. This is how paper beats rock. Organic activity, the growing of plant roots and other organic activity that expand pre-existing fractures in rocks. fractures, breaking of rocks. And great picture here, the one on the left, where the root systems can actually go into the spacing of these rocks, and the roots become bigger and thicker over the course of time and can really almost like pulverize the rock. Alright, and the last physical breakdown is called exfoliation. When rock once located deep in the earth are brought up to the surface. This can be uplifting forces, causing them to depressurize and peel off in layers. Alright, so here's a pretty good example of something that we saw last year for exfoliation.
Ho, ho, ho. Ho, ho, ho. Ho. All the way down. This whole seam now is active again. Lots of activity down below. It's still lifting. You see that? It just popped right up. Little piece flew into the air. Yeah, baby. Now maybe you'll be happy. Everything is flat again. All those pieces that were lifting just went back down.
Alright, so that's a great example of exfoliation. Alright, let's get into chemical weathering. Alright, so the process by which rock is broken down through chemical means, with changes made to its chemical composition and physical properties. For example, changing its hardness, maybe becoming softer, and color. Alright, so first type is called oxidation. When iron-bearing rock, iron is Fe by the way, when iron-bearing rock are exposed to water and oxygen, resulting in the formation of rust. So we have a bike chain, iron, exposed to water and air, producing rust. This rock sample has some iron in it and looks like it's right near water and from rainstorms, and we have rusting here on that pretty big rock. Alright, number 2 is hydrolysis, when water is added to the chemical structure of a mineral, causing the chemical bonds in that mineral to break, becoming weaker, and this can eventually dissolve a mineral. Number 3, carbonation, when acid rainwater dissolves vulnerable minerals in a rock. So here's a sequence of it. We have sinkhole formation, where we have some rainwater that falls mixing with CO2, and that carbon dioxide water mixture, that carbonic acid, goes into the soil, and we have some weak rock. And this weak rock is limestone, and limestone will dissolve with acid, producing a cavity. And sometimes these cavities can be large enough where the ground cannot be supported and eventually would fall into this cavity. I want to go back to a great example that we saw last year. Alright, so this is a sinkhole in Louisiana.
I got it.
So these massive trees that could be roughly 30, 40, 50 feet in height, just getting pulled in, cannot be supported anymore. Pretty impressive. So not only are the trees going in, but all that water in this lake is going into that big cavity. It's like rushing in. Right, now the lake and that sinkhole are going to get equalized. looks like we're good. Pretty impressive, though, gotta say. So carbonic acid weathers limestone. All right, limestone has a mineral called calcite in its makeup and its composition. And if you go to page 16 of your reference table, the mineral calcite reacts with acid. All right, so this carbonic acid weathers limestone, creating caves, caverns, and sinkholes. This is a great movie. You guys should definitely watch this movie called The Goonies. Probably one of the best 80s movies out there. And it's a series of these characters who are running away from some evil people. But a lot of this takes place in caves, which is pretty cool. And right now, one of the lead actors and a lot of the other actors in the movie are all hanging to the ceiling of the cave, and those formations are called stalactites. So inside caverns, we have a thing called stalactites with a C for ceiling, and stalagmites with a G for ground. Alright, so in your picture, please make sure you include the word stalactite and stalagmite. Alright, so we have sinkholes in the field. A lot of this happens in Florida. Florida has a lot of limestone below its surface. And not only is Florida bad for hurricane season, but it's also pretty bad for these sinkholes. Sinkholes in your backyard. Sinkholes in the city. It's a pretty massive sinkhole. Alright, and the last important thing, the last final one for chemical breakdown, is organic decay. Organic decay occurs when acids are dissolved in water from plant and animal decay. So we have plants that are what we call deciduous, that will lose or turn color and eventually would die out, and can add some acid into the soil. And along with, once living things that are now, maybe scavengers got to this, and the microorganisms in the air have been decomposing this, but it's also going to put a lot of those acids into the ground too, causing it to decay chemically, right? Changing its chemical composition. Alright, so after this lesson, you should be able to know that there are two means of weathering, right? Again, mechanical, which is physical, and chemical. Number two, there are 4 types of mechanical weathering. Just to review, we have ice wedging, or frost action, or frost wedging, and we have freezing and thawing. We have abrasion, we have exfoliation, and organic activity. Those are your 4 main ones. Number 3, mechanical weathering affects just size and shape. Number 4, there are 4 types of chemical weathering. We have oxidation, we have hydrolysis, we have carbonation, and organic decay. Those are your 4 types. And then number 5, chemical weathering affects the chemical composition of that material. Right, it's going to be changed. All right, so be ready for tomorrow. We'll review this, take a few questions based on this flip lesson, and answer a few Regents type questions for an activity for tomorrow. Have a good night, and thank you.